All right, we're going to start chapter 9, section 1, solving linear and nonlinear systems of equations using substitution. All right, now these are the steps to using substitution. As always, it's easier if we just do it, but this is the summary for the steps, right? So you either want an x equals or a y equals, substitute it in for the other equation, solve for whatever variable you have, and then you plug it back in for the other missing variable. All right, so like I said, you always want, with substitution, you want either an x equals or a y equals. All right, if you don't have that, you need to manipulate one of the equations so that it looks like that. Number 1 and 2 are pretty simple equations, so it doesn't really matter what you do, what variable you choose to get isolated, and in which equation. All right, so in number 1, let's say I want to get x by itself. Right, and if I want to get x by itself, notice that on this side of the equal sign, there's a plus y. So all you have to do is subtract y on both sides, and then you get x equals 4 minus y, right? And that gets us our x equals. All right, and then once that's done, you want to substitute this expression, 4 minus y, into the other equation that you didn't touch, right, for x, right? I see an x right here, but we know that x has to equal 4 minus y. So I'm just going to replace that x with a 4 minus y, and then leave everything else the same. All right, in this case, 4 minus y, all right, minus y and minus y is going to get you a negative 2y. And then so I get 4 minus 2y equals 2. I can subtract both sides by 4. And so I get negative 2y equals negative 2. And then divide both sides by 2, and so I get y equals 1. All right, so then that gets us one of our variables, right? This is a system, though. All right, so I need to plug it back in to one of my equations. Now, in substitution, there's a little bit of an advantage where you already have one of your variables isolated. All right, so you can just go ahead and plug that into your isolated equation, and then you get your answer straight away. All right, so here we get x equals 4 minus y, which is 4 minus 1, which is 3. All right, so I get x equals 3. And your answer is always going to be written as an ordered pair, right? So it's always x comma y, so 3 comma 1. All right, so it's always an ordered pair. In a system of equations, you're always going to have two lines, right? Whether you graph the lines or not, they do exist as lines. All right, so sometimes you get two lines that intersect, which is one solution. All right, in this case, we had one solution. All right, sometimes you get two lines that never touch, right? So two lines that are parallel, that gets you a no solution. Or sometimes you get two lines that are exactly the same line, right? One right on top of the other, and that's infinitely many, right? So your solutions to these kinds of problems exist as a representation in the coordinate plane. Right, so we write it as an ordered pair because it represents a point where lines intersect. All right, so let's do the same thing with number 2. Again, using substitution, the goal is to get either an x equals or a y equals. All right, you're always going to want to do whatever looks simpler, whatever doesn't have a coefficient. All right, so if you look in the first equation, I already have a positive x on one side. All right, so let's try to get that by itself. And to get that by itself, we can add y to both sides. So then you get x equals y. All right, and then from here, all you have to do is replace the x that you see in the second equation with a y, right? Because I already know that x equals y. So this is going to get us 5 times y minus 3y equals 6. And then 5y minus 3y is going to get you 2y. So I get 2y equals 6. Very simple algebra, so we get y equals 3. All right. And then once again, you want to plug that back into your original equation or your manipulated one, right? In substitution, it's easiest to plug it into the one that already has the variable isolated. Replace y with 3, and so you get x equals 3 as well. All right, so then your answer as an ordered pair is going to be 3 comma 3. All right. Now, sometimes you get some word problems. So in the word problems, you're always going to have two equations. Typically, you have money problems, right? So this is a money problem, in particular, a money problem involving investing in two funds that gain simple interest, right? So both of your equations in this case are going to represent money, right? But sometimes, I mean, the context you're just going to have to tell based on whatever the scenario they give you is, right? Sometimes it's you're trying to buy some items. You might see like landscaping problems with like, I don't know, some sort of potted plants versus, I don't know, sod. Right? And you want to try to find the cost of each item. Or you sometimes you see like, I don't know, sometimes there's a concession stand that's selling drinks and pizza or something like that, and you're trying to find the cost of a drink versus the cost of the pizza, right? And so it really just depends on the problem that you're given, right? In this case, the best way to go about the word problems is to annotate as you go along, right? So I have $12,000 invested in two funds, right? So I have two different funds. I can call those X and Y, right? I'm investing in two funds, X and Y, and the total between those two funds is $12,000. So sum total is going to get you 12,000, right? And I know that X plus Y, the amount that you invest, has to equal 12,000, right? Simple interest is going to be 5% and 3% in this case, right? We want to use these as a decimal. Anytime you're doing math with percents, always write it as a decimal. So I get 0.05 and 0.03. So I'm just going to say that 0.05, right, so 5% of X of one of my funds can be represented as such, and then 3% of another fund, so 0.03 times Y. And we know that the annual interest was $500, right, and this in red represents our interest. So I'm going to say that this equals $500. All right, so then labeling our two equations, this is the amount invested, and then this is the amount in interest that we're getting. All right. So each of your two equations are always going to represent something, right? And then now we solve it, right? I want to find how much is invested at each rate. The best way to go about decimals, I would say, is to just get rid of them entirely. All right, so I like to move the decimal place over the same amount of time each time, right? And if you have a whole number, you have imaginary zeros as placeholders. All right, so just write it, move it over twice. And then you end up with something like 5x plus 3y equals 50,000. All right. And so now we can do a substitution, right? In our first equation, the blue equation, we can get one of our two equations, one of our two variables isolated. Doesn't really matter which one, right? Let's say I subtract y on both sides, right? Then I'm going to get x equals 12,000 minus y. All right, so what does that mean? That just means anywhere that I see an x, I'm going to replace that with a 12,000 minus y. All right, so this is going to get me 5 times 12,000 minus y plus 3y equals 50,000. And then I just want to simplify this, right? 5 times 12,000. Well, 5 times 12 is 60. And there's 3 zeros at the end, so this is going to get us 60,000. 5 times negative y is negative 5y. So I get 60,000 minus 5y plus 3y equals 50,000. And then combine like terms. And then get your constant to one side. All right, so I get negative 2y equals 50,000 minus 60,000. Combine these, that's going to get you negative 10,000. All right, so I might write this a little bit better. So negative 2y equals negative 10,000. And then you can divide both sides by negative 2. Again, 10 divided by 2 is 5. Negative divided by negative is positive, and there's 3 zeros at the end. So I know that my answer for y is going to be $5,000. All right, so that means you invested $5,000 in the account that earns 3% simple interest. Now to find the one that earns 5% simple interest plug it into your substituted expression. All right, so this is going to get you x equals 12,000 minus 5,000. And so 12,000 minus 5,000 is going to get you 7,000. So that means you invested $7,000 in the account that earns 5% simple interest. All right. We can do the same thing for the second one. Because it's the same thing, I'm just going to set it up for you guys, and then you guys can try to solve it on your own. All right, so we have kind of a similar setup, right? $25,000 invested in two funds. I can call those X and Y. So I know that if I did X plus Y, and I added the amount that I invested, then it should total 25,000. All right, 6.5% and 8.5% simple interest. Okay, well, as a decimal, that's going to be 0.065. All right, times the amount in one fund plus 0.085. Right, so 8.5% of the other fund. Our interest that we earned was $2,000. All right, so these are going to be your equations. All right, and then once again, you guys can try to solve this in a similar manner. All right, so you can really do it however you want. But with the decimals, again, I like to move the decimal place over. In this case, if I moved it over 3 times, I would put 3 placeholder zeros. All right, so we get 2 million in this one. All right, but then once again, you do just want to get one of your variables by itself, right? So x or y in the blue equation, and then substitute it into the second equation. All right, and then you find out how much you invested. All right, now with nonlinear systems, these are any sort of system that you see with an exponent over a variable. Now we've done different kinds of nonlinear functions, right, with graphing them, right? So sometimes you have seen a parabola, and now in this parabola, maybe you have a line going through it, right? And if you have a line going through it, right, that's as if you had 2 points right here going through it, you have 2 solutions. Right? If I have a line going through a parabola, you could have 2 solutions. Sometimes maybe you have one solution and it's just barely scraping 1 point on your parabola, right? This is just one solution. Sometimes you get no solution. Sometimes you have a line that is nowhere near your parabola, right? So a no solution case. All right, so this is just one example of a nonlinear system. You might have, I don't know, another kind of nonlinear equation that we've seen before are circles, right? So maybe I have a circle somewhere right here, but still I have a line, right? And if you guys remember this line that touches 2 points, right, this is called a secant line, right? So a secant line always touches your circle at 2 points, right? So you could have 2 solutions. All right, another geometry vocab for you guys. If you remember, a tangent line touches at only 1 point. So we have 1 solution. Sometimes you have a line that isn't touching it at all, and it's another no solution, right? So there's a bunch of different cases that you might see, right? And then maybe some more complicated cases that we won't get into in this class, right? But just so that you are aware that they exist, right? Maybe you have a parabola with a circle, all right? And then you have 4 solutions. All right, I'm sure you can imagine that would require quite a bit of work to get all 4 solutions, right? But it's possible, right? Maybe you get a parabola with a circle, but the parabola is inside of it, and then you still just get 2 solutions, right? So there's all sorts of different cases, right? And you can even mess around with it and make all sorts of crazy shapes and stuff of things that you guys have seen before. All right, but really the one that's going to make up majority of the focus of this class is a quadratic with a line. A quadratic with a line might be one of the simpler kinds of nonlinear systems that we do. And again, it's good to be aware that some of these other ones exist, but we don't really need to spend too much time going over these. All right, so among these examples, I'm only going to do 5 and 6. All right, that's where I stopped with you guys in class. So just these two examples, and that'll be it for the lesson. All right, and okay, so let's get started. Let's look at number 5. Once again, I'm still doing this using substitution. All right, so the goal is to get one of your variables by itself, right? Always pick whatever looks simpler, right? I wouldn't want to try to get y by itself in the first equation, so we can try to do that in the second equation. All right, in the second equation, it's easiest to get y by itself instead of x, just because if I wanted to get x by itself, not only would I have to add the y, I would have to divide by 2, and that would get you a fraction. All right, and then you'd have to end up squaring an expression with a fraction, and then it gets a little messy. All right, so let's try first getting the y by itself. So what we can do, we can subtract 2x on both sides, and then we get negative y equals negative 1 minus 2x. And then to get rid of that negative in front of the y, we can divide by a negative 1 everywhere. So then I get y equals 1 plus 2x. All right, and then what we can do now is we can plug in 1 plus 2x wherever we see the y in the first equation. Right? I only see one y right there, so that's where I'm going to plug it in. So it's going to become 3x squared plus 4x minus, and instead of y, I'm going to put 1 plus 2x. All right, and this is going to equal 7. All right, distribute that negative. So this is going to get us to 3x squared plus 4x minus 1 minus 2x equals 7. And you can combine like terms, get everything on one side. Remember, with quadratic equations, you want to get them equal to 0. So we can subtract 7 and then combine 4x and negative 2x, right? So this is going to get you a 3x squared plus 2x minus 8 equals 0. Wait, hang on. Let me use a thinner pen. All right, I might need more room. And now we have a quadratic equation that we can factor. All right, so let's try doing 3 times negative 8, which is negative 24. Let's see if when we find factors of this that add to 2, if it helps us in this problem. All right, and in this case, we're going to do 6 and negative 4. All right, so then a couple ways that you guys could do it. I think I showed you guys grouping. So I'm going to do a 3x squared plus 6x minus 4x minus 8. All right, and then you can group the first two, group the second two, and then you can take out a GCF from the first group. It's going to be 3x and an x plus 2, and in the second group, you can take out a negative 4. All right, and then 3x and negative 4 become their own factor. All right, x plus 2 shows up once. Okay, so this quadratic equation is going to factor as follows. And then from here, you just need to set each of your factors equal to 0. So then I get x equals negative 2. Right, you can add 4 and then divide by 3. So I get x equals 4/3. All right, so we get 2 solutions here for x. All right, but now keep in mind, this is a system, right? We're not finished. We need to plug in each of these into our original equation, right? One of our 2 equations. It's easiest, again, to do it to the one that's already isolated, y. All right, so then this is going to be y equals, let's start with 4/3, right? If I plug in 4/3, then this is going to get us y equals 1 plus 2 times 4/3. And this is going to get you 1 plus 8/3. And then 1 we can rewrite as 3/3, right, to get a common denominator. And this is going to get us 11/3. All right, so y is 11/3. All right, so then one of my ordered pairs is going to be 4/3, comma 11/3. All right, to get my other solution, all right, just plug it in. X is negative 2, I'll plug it into this equation right here. So then it's going to be y equals 1 plus 2 times negative 2, which is 1 minus 4, which is negative 3. All right, so my other solution is going to be negative 2, negative 3. All right. All right, so a little bit tedious, right? It wasn't particularly challenging math. It was just a little bit of more work than it was before. All right. So let's finish up with this one. Once again, let's try to get one of our variables isolated. All right, so I'm going to go ahead and in our first equation, I'm going to get the y by itself. Right? It seems like that's easiest. So I'm going to add 2x on both sides, and I'm going to get y equals 5 plus 2x. All right, and then 5 plus 2x we can substitute in our second equation. All right, and this is going to become an x squared minus 5 plus 2x plus 3x equals 1. And then I can distribute that negative, and then this is going to get us a quadratic equation. So we're going to get x squared minus 5x minus 2x plus 3x equals 1. Again, quadratic equations you always want equal to 0. Oh wait, hang on, I wrote something wrong. That's just 5, sorry. So we can subtract 1 on both sides, combine like terms. So this is going to get us an x squared plus x minus 6 equals 0. And then I want factors of negative 6 that add to a positive 1, and that's going to get me a positive 3 and a negative 2. And so your two solutions are going to be negative 3 and positive 2. All right, but once again, I want to plug these in to our isolated equation. So this is going to be, let's start with negative 3. All right, so for x is negative 3, we're going to get y equals 5 plus 2 times negative 3, which is 5 minus 6, which is negative 1. So one of my ordered pairs is going to be negative 3, comma, negative 1. All right, and then for x equals 2, it's going to be y equals 5 plus 2 times 2, which is 5 plus 4, which is 9. So then my second ordered pair is going to be 2, comma, 9. All right. So again, visually on a graph, it might look something like, I don't know, if I have a point at negative 3, negative 1, and a point at 2, 9, right? You might have a parabola, something like that, with a line going through those 2 points. All right, so that's visually what it looks like. Right, but you don't need to occupy yourself with what it looks like, right, as long as you know how to do the math behind it, right? But that's what your answer represents. All right, and that's as tedious as these kinds of questions get with substitution. All right, and the next lesson we're going to do elimination.